While giving the IUPAC name to alcohol, at that time the E which is present in the parent alkane, so let me write alkane, this E should be replaced with the OL. So this will become alkanol. Let me write by using this color. So this will become alkanol. While writing the IUPAC names to all the alcohols, at that time we have to use all IUPAC nomenclature rules. Now let us take some examples and we'll try to write down the IUPAC name to these compounds. Let me write the first example. So this is CH3, 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 CH2OH. Now in this compound you can see that this compound is primary alcohol because this OH group is present to this carbon atom and this carbon is attached to the single carbon atom. It means that only one hydrogen is replaced by this substituted alkyl group. While giving the IUPAC name at that time, we must start the numbering to this carbon atom because OH group is attached to this carbon. Therefore, this will become 1, 2 and 3. Now here you can see that different substituents are present. Here at carbon number 2, two methyl groups are present. So we must write 2,2-dimethyl. And the total number of carbon atoms are 3. So parent compound is propane, but alcohol is or OH group is present on carbon number 1. So this will become 1-propanol. If we combine these two at that time, we'll get the final IUPAC name. So this will become 2,2-dimethyl 1-propanol. Now let us take a little bit the complicated example. So let us draw the structure like that. So we have OH, here is the substituent. You can also put the substituent over there, one methyl group and the chlorine group. While writing the IUPAC name to this compound at that time, we can start the numbering from left hand side towards the right hand side and from right hand side towards the left hand side. But here we have to take precaution that the carbon where OH group is present, that carbon should get the lowest possible number. So we must start the numbering from left hand side towards the right hand side. So this will become 1, 2, 3, 4, 5, 6 and 7. It means that we have 7 carbon atoms in this compound. So parent compound will become heptane, but OH is present at position number 2. So this will become 2-heptanol. Now let us take the other substituent. So we have ethyl group at carbon number 3. So we must write as a 3-ethyl. Then we have chlorine at position number 6. So we must write as a 6-chloro. 6-chloro. And then we have one more substituent, that 6-methyl. While writing the complete IUPAC name at that time, we must check the alphabetical order of this substituent's name. So here we have E, C and M. At that time here C will come first while writing the final IUPAC name. So we must start with 6-chloro. then E will come. So this will be 3-ethyl, 6-methyl, 6-methyl, 2-heptanol will be the final IUPAC name of this compound. Now if compound contain the cyclic rings, for that also we can give the IUPAC name. So let me draw the structure. If we have the cyclic ring like this, we can put the OH over there. Now here you can write the numbering to that carbon where OH group is present. So this will become 1, 2, 3, 4, 5 and 6. Here you can start in anti-clockwise direction also, because there is no any substituent. So we can start clockwise as well as anti-clockwise direction. But if substituents are there, at that time we have to take precaution. Here OH group is present on cyclic compound, so we must use the cyclo as a prefix while writing the IUPAC name. So this will become cyclohexanol, because total number of carbon atoms are 6. So this will become hexanol. Now let us take the example where two OH groups are present. So if we have the 6-member cyclic ring with two OH substituent. So here, while writing the numbering to this ring, at that time we must start 1. So this will become 2, 3, 4, 5 and 6. While writing the IUPAC name, at that time here two OH groups are present. So we must write 1, 2, cyclohexane, cyclohexane, diol, cyclohexane, diol. Now let us take the example where the carbon-carbon double bond is present as well as the OH group is present. So let me draw the structure like that. So we have double bond over here and the OH group over there. So here we can start the numbering from left hand side towards the right hand side and from right hand side towards the left hand side, but here OH group has highest priority, and that's why we must start from right hand side towards the left hand side, so that this carbon on which OH group is present should come the lowest number. So this will become 1, 2, 3, 4, 5 and 6. While giving the IUPAC name, at that time we have to take precaution that 3 we have carbon-carbon double bond, and that number should reflect in the IUPAC name. So we must write 3-hexene, 3-hexene. Now we have OH at position number 2, so this will become 2-ol. Hope you will understand the IUPAC nomenclature of alcohol from this video.